Okay, so from where I stopped, this is the working. This shows the indicator for the mixer. So anytime that the mixer is working, this light will show, which indicates that the mixer is working. This one is also for the block molding. The same thing applies to that. And here we have these yellow indicating lamps, which is one is for the overload trip. Anytime the overload trips, then this indicating light will be on, which also shows that the overload has tripped. The same thing also applies to the block molding. Yes. Now, this is the emergency stop push button. This emergency stop push button is anytime there is a bend, or you sense for anything like bend, or any electrical leakage or any electrical hazard. Yes, it is purposely for electrical hazard and that. So you immediately approach this, and then you just click it off. You just push it off, then the contact will open. Now let me show you inside. These are the control. This is the control board. This is partitioned into two. Now this one is for another, is for a different motor, and this one is also for another motor. This is for the mixer, and this is also for the block molding. Now I'm going to first of all want to show you the components, their names, and how they are functioning. This is RCCD. This one too is three-phase RCCD. This one is also the controls breakers. This one will control the phase monitor. Yes, it will control the phase monitor. Now here we have our contactor, magnetic contactor. Yes, anytime that the current flows, then the contactor will magnetize. When the contactor magnetizes, or anytime that the contactor energized, then the contact will close. When it closes, then it allows the current to flow through the overload, and the overload then to the machine, to the motor. Then it permits the motor to work. Now this is, let me show you, this is a phase monitor. Phase monitor. These are the relays, the control relays. I don't, it's not necessary for me to use these relays, but there is a reason behind me using these relays. First of all, let me go with these monitors first. This monitor is voltage monitoring device for three-phase. Now there are some parameters here. We have under voltage, we have over voltage, and then we have the timing, the delay, that the seconds. So you have set it, you have set your parameters here, and then if there is any over voltage, then the over voltage light will indicate. Anytime the over voltage light indicates, then it tells that there is an over voltage, and this is also under voltage sign. This under voltage is also there for the under voltage sign. Yes, so these are the parameters. I've set it depending on the voltage which is on the component. Then this is also 220 AC, 220 volt AC relays. The relays also, the reason I added the relay here is that if maybe the face monitor can work to a certain times, or it can work to a certain let's say a certain period, like 1 year, 2 years, and all that it can spoil. So if the when it happens that the face monitor works no more, then these relays will also do the work for the for the face monitor. It will place as the face monitor. This one, what it does is that the difference between the face monitor and the relays here is that the relays are used for the for the face, to check the face. When there is a face failure, then the relay will not work. There will be an open contact, so that one too, the motor will not work. That is the difference. It doesn't have any parameters, it doesn't have any under voltage, it doesn't work, it doesn't have any link with phase failure, it doesn't have any links with um, delays and all that. But what it does is, it does only one job. It will just fail, it will just open contact when there is a phase failure. This is the work of the relay. When we apply to this, is different from this, because the phase monitors, it monitors the voltage, the current, it monitors the voltage. When there is under voltage, it also monitors the phase sequence and all that. So the same thing here applies to this also. We have our phase failure device, and the same thing, the same connection which I've used the relays here, the same thing that I've done here. So it also do just one work, just to open contact when there is a phase failure, only the relays. But the phase monitor here also, as I said earlier, for this one, this too is also, it does the same work as this. It monitors the voltage, the phase when there is an over voltage, when there is under voltage, it will also indicate, and it will not, the relays will just open, it will just open. Now this is also a single pole breaker for this also controls, it controls the lines here, it controls here. These are the indicating wires, which I have dressed it very nicely here. So this is how this machine, this is how it is designed. This is DOL starter control panel, direct online control panel. This is for overload relays. We have our contactors, the same thing here. We have our RCCDs and all that. So this is how it works. This is how it works. Now I'm going to show you the current direction. I'm going to show you the working principle of this design. Now let's use this for an example. Use the block molder, the design for this place, for the block molder. Let's use this for an example before we move to the other side. Now I want to on my machine. Sorry, it's unfortunate we've not powered it. It's unfortunate there is no, we don't have our meter yet. So I'm just going to use just sign and show some simple instructions here. Now if I want to on, let's say if I want to on this, I'll just click here. Now I'm showing the current direction. When you click here, the current, assuming there is power inside, there is the power is working, there is a meter here, so assuming there is a power here, so immediately I on this one. If I remove my hand, the contact will just return. It will just return. If I click here, the contactor will just close. But if when I remove my hand, it will just come back. The contact will just close again. So in this application, we have to deceive the contactor by taking a bypass current from the output of the stop button. So from the stop button, then you terminate it on inside the normally open of the contactor. From the normal open of the contactor, so then you connect the output of the normal open of the contactor. So you take the bypass current from the output of the stop button, then you terminate it under the contactor, the normally open, the output of the first contactor, the block model contactor. Now, so assuming there is current, a bypass, so this is our bypass current. So you just click, and then when it opens, the bypass current will just flow. Then it will deceive the contactor to energize. When the contactor, now if I remove my hand, because of the bypass current which I have terminated here, the contactor will just energize. Then it will allow a close contact for the mixer to operate or to function. Now the same thing applies to this. The same thing applies to this. So these are just a brief current direction which I am showing, or which I have shown to this application, this door starter. So the next video, I'm going to show you a star delta, how a star delta, the working principle of a star delta, and also the current direction of a star delta connected motor. So thanks for watching. God bless you all.